Welcome to this video tutorial on estimation and the calculation of confidence intervals. You can pause this video at any time if you want to recap, if you want to see if you can do the next step before you're shown how to do it, or if you want to use this tutorial as a guide for doing another similar problem. We will use problems 4b from the Applied Statistics textbook, and I will go through problems number 2, 4 and 6. This allows us to calculate a confidence interval for a mean when sigma is known, the confidence interval for a mean when sigma is unknown, and also a confidence interval for a population proportion. So we'll begin by calculating a confidence interval for a mean when the sigma, the population standard deviation, is known. This doesn't always happen, but when it does happen, when we do know the population standard deviation, then we use that, and we use formula 4.4, which states that mu, the population mean, equals x bar, the sample mean, plus or minus 1.96 times sigma over root n. Of course, we need to know sigma, the standard deviation of the population in such a case. Now, this problem number 2 tells us that the standard deviation of the diameters of plastic tubes is known. It's 0.05. 5 tubes were randomly selected, so we have a sample size of 5 from today's production, and their diameters were measured, and those are the results in millimeters. We want to construct a 95% confidence interval for the population mean, so we use this formula 4.4. We will need x bar, the sample mean, and we will need n, the sample size. We do not need to calculate the standard deviation from the sample because we already know the population standard deviation, sigma, which is better. So x bar, putting these numbers into a calculator in stat mode, or otherwise we can find that x bar for these data is 12.054. And n, of course, equals 5. So that's all we need then to substitute into the formula. So substituting, we get mu equals 12.054 plus or minus 1.96 times sigma is known to be 0.05 over the root of 5, the sample size. Now this here is the point estimate. Mu equals 12.054 plus or minus, this is the margin of error. So multiplying these together in our calculator, we get 0.044. Multiplying 1.96 by 0.05 and dividing by the square root of 5. So we subtract the margin of error from the point estimate, and that gives us 12.010. And we also add the margin of error to the point estimate, and that gives us 12.098. So that there is a confidence interval for the mean of that population. Now we need to state that in words. So we need to say that the mean diameter of all the plastic tubes made by that process today lies between 12.010 and 12.098 millimeters with 95% confidence. Notice that when we say it in words, we're referring to the population, all of the plastic tubes made today. We're not describing the sample, we're using the sample to make an inference about the population. We also mention what the measurement is, and we mention the two limits and our 95% confidence. So we calculate the confidence interval, and then we express in words what that means. The next problem we look at is problem number 4 from the same set of problems. In this case, the population standard deviation is not known, and so we will have to estimate the standard deviation using the sample data. So a large number of delegates attended a week-long conference. A random sample of 5 delegates was selected, and the expenses that they each had incurred on food and accommodation was observed in euro as follows. And there's our random sample. Construct a 95% confidence interval for the population mean and express your answer in words. Now in this case, we will use formula 4.5, which says that mu equals x bar plus or minus t times s over root n. That's t n minus 1. Just a reminder of what the appropriate value is to use for t. So s is the standard deviation estimated from the sample. X bar is the mean, also which we get from the sample data. N is the number of values in the sample, and t we take from the t tables. So for this, we'll need to use our calculator in stat mode. So having turned on the calculator, we choose stat mode and the simplest stat mode available, and we enter the data. So 848, data entry, 884, data entry, 902, data entry, 721, data entry, and 812, data entry. If you have a different calculator, your procedure might be a little bit different, but whatever you do, you enter the numbers into the calculator in stat mode, and then you press the key for the mean. X bar is 833.4. So in this case, X bar equals 833, I'll say 0.40 since it's money. I'll just go to 2 decimal places. S, the standard deviation, press the S key. I get that's 71.71. So S equals 71.71. N, of course, is 5, number of observations in the sample, and we'll also need T, n minus 1. So n is 5, so there are 4 degrees of freedom. N minus 1 is 4. So we'll go to the tables of T with 4 degrees of freedom, and it's a plus and minus. There's a plus tail and a minus tail. So with 95% confidence, the two tails together comprise 5%, so each individual tail contains 2.5%. So when we go to the tables of T, we look in the 2.5% column, in the row for 4 degrees of freedom, and we find that the value we require is 2.776. 2.776 is the value of T. That will provide us 95% confidence for a two-sided confidence interval. So now we can substitute all of these values into this formula. Mu equals x bar 833.40 plus or minus 2.776 times 71.71 divided by the root of 5. So as before, we have a point estimate and a margin of error. So we can say that mu equals 833.40 plus or minus, and if we calculate all of this with our calculator, we get 89.03. 89.03. So if we subtract 89.03 from this quantity, and I'm just going to round it off to the whole number of euro, it's 744. And if we add this quantity, and again I'll just round it off to the nearest whole number, I get 922. So there's our confidence interval. We can state with 95% confidence that the population mean lies between those two values. Now again, we will need to state that in words, and so we need to say something like this. The mean expenses incurred on food and accommodation by all the delegates attending that conference lies between €744 and €922 with 95% confidence. We're making a statement about the population mean. We are referring to the population and to the measurement involved, all the delegates, their expenses incurred in food and accommodation in this case, and we're saying that that statement can be made with 95% confidence. Okay, our next example will involve estimating a population proportion. So the problem here says that out of 633 students randomly sampled at a university campus, 105 walk from home to their classes. Construct an approximate 95% confidence interval for the population proportion. Express your answer in words. So the formula we will use is formula 4.6, which says that pi, which is the symbol we use for the population proportion, pi, the Greek letter P, pi equals P, the sample proportion, plus or minus 1.96 times the square root of P times 1 minus P over n. So in this case, we have n equals 633. The sample size was 633. N equals 633. And in this case, P is the proportion of the sample that were yes. It's a yes-no situation. Either they walk to their classes, yes, or they do not, no. So the number who are yes is 105. So the proportion that are yes in the sample is 105 divided by 633. And that is 0.1659. I'm rounding that off at 4 decimal places. Okay, so we have the values that we require to substitute into the right-hand side of the formula. So we now do that, and we say that pi, the population proportion, equals P, 0.1659, plus or minus 1.96 times the square root of 0.1659 times 1 minus 0.1659 divided by 633. So again, we have a point estimate and a margin of error. So I'll just write down again the point estimate, 0.1659 plus or minus. I'll calculate this quantity here using the calculator, and I find that that quantity is 0.0290. So I will subtract this quantity from this, and that gives me 0.1369. And when I add this margin of error to the point estimate, I get 0.1949. So that's my confidence interval expressed as a decimal. I'll express it as a percentage, and I'll round it off to 3 decimal places. That's 1 decimal place of a percentage. So 13.7% and 19.5%. So again, I need to be able to state that in words. So what I say is that between 13.7% and 19.5% of all the students at that university campus walk from home to their classes with approximately 95% confidence. So there we have a confidence interval for a population mean, where sigma can be either known or unknown, and a confidence interval for a population proportion, where we have a yes-no outcome, and we want to estimate the proportion in the population that are yes.